500 builds queued in minutes. All agents vanish during a node drain, leaving connection refused errors. The culprit? No preStop hook on the pods. Let's break down Jenkins Kubernetes deployment, how it works, and the exact mistake behind that failure. Jenkins Kubernetes deployment is the practice of running the Jenkins controller as a deployment in a Kubernetes cluster, and using the Kubernetes plugin to dynamically provision, build agents as ephemeral pods. The controller stores its state on a persistent volume to survive pod restarts. The controller runs as a deployment with a single replica and uses a persistent volume claim for JNLP home. Agents are ephemeral pods managed by the Kubernetes plugin. The controller must have a service account with permissions to create, list, and delete pods in the agent namespace. JNLP home must survive pod restarts. We use a persistent volume claim with read-write-once access mode, backed by an elastic block store volume. For workspaces, we use a shared PVC with read-write-many to avoid data loss during node drains. The pod template defines the agent's container spec, including image, resource requirements, environment variables, and volumes. We create multiple templates for different build types and pin the agent image version to avoid unexpected changes. Without proper resource limits, one build can starve others. We set CPU and memory requests limits on both the controller and agent pods and use node selectors to schedule agents on specific node pools. We also configure a maximum number of agents per cloud and a timeout for idle agents. Agent pods communicate with the controller via JNLP on port 50,000. We use a cluster IP service and network policies to restrict access. For external access to the Jenkins UI, we use an ingress with TLS termination. Using Jenkins configuration as code plugin, we define the entire Jenkins configuration in a YAML file stored in Git. This ensures that every controller pod is identical and can be recreated from scratch. We deploy the Prometheus plugin on Jenkins and expose metrics at Prometheus. Key metrics include queue length, executor count, build duration, and job status. We set up alerts for queue depth, agent provisioning latency, and JVM heap usage. When a node is drained, agent pods receive a SIGTERM signal. Without handling, builds are killed instantly. We add a preStop lifecycle hook that sends a shutdown command to the agent process and set a termination grace period seconds of 60 seconds to allow builds to complete. During peak hours, the number of builds can spike 10x. We use cluster autoscaler to add nodes when pods are pending and spot instances for cost savings. We also set a maximum number of concurrent agents and implement a queue-based throttle. We back up JNLP home every hour using a cron job that creates a snapshot of the PVC. The backup is stored in a simple storage service bucket with versioning. For disaster recovery, we have a script that deploys a new Jenkins controller from scratch using the latest snapshot. This is the same issue we highlighted at the start. Here's exactly why that happened. We assumed Kubernetes would gracefully terminate pods, allowing Jenkins to reconnect after rescheduling. But agent pods had no preStop hook or grace period. When the node was drained, pods received SIGTERM and were killed immediately. Jenkins agents had no chance to disconnect cleanly or transfer workspace state. Agent pods had no preStop hook, so during node drain they received SIGTERM and were killed immediately, causing builds to fail with connection refused errors. The fix was to add a preStop lifecycle hook to agent pods that sends a shutdown command to the Jenkins agent process with a 30-second timeout. We also configured the Kubernetes plugin to use a persistent workspace volume so that even if the pod is killed, the workspace data survives. This resolved the incident and prevents recurrence. This gotcha is exactly the incident we just covered. Without a preStop hook, agent pods are killed immediately on node drain, causing build failures. Always add a preStop hook to gracefully disconnect. Without resource limits, one build can consume all node resources, causing other builds to fail with out-of-memory error or run slowly. Always set both requests and limits on agent pods. Exposing the JNLP port via a load balancer allows anyone on the internet to connect to your Jenkins controller. Always use cluster IP and restrict access with network policies. The Kubernetes plugin 1+ mentioned in the article requires Jenkins 2.44+. However, the preStop hook for agents must be configured in the pod template YAML, not in the plugin UI, as the plugin's pod template editor does not support lifecycle hooks. Use a YAML pod template via JCasC or a custom pod template file. The article mentions preStop hooks for agents, but does not show the YAML snippet. Here is a concrete example for the agent pod template in JCasC, using a preStop command that gracefully disconnects the agent via the Jenkins CLI. The article advises pinning agent image versions, but does not emphasize that using latest can cause silent failures when the image is updated. Always use a specific digest, e.g., Jenkins/inbound agent at SHA-256, to ensure immutability and avoid unexpected changes that break builds. To diagnose agent issues, start by checking pod logs and events. Use kubectl describe pod to see the reason for pending state and kubectl logs to view agent output. Also verify that the Jenkins URL in the Kubernetes cloud configuration matches the internal service DNS. Let's run through some common interview questions. How does K8's plugin provision agent pods? Plugin watches queue, creates pod via API, agent connects via JNLP. How to secure JNLP port? Use cluster IP service, network policy disable if using Kubernetes plugin. How to debug pending agent pods? Check pod events, resource availability, PVC status, node selectors. And a few frequently asked questions. What's the difference between agent and pod? Agent is logical executor, pod is the container running it. How to set Jenkins URL for agents? Use internal cluster DNS, e.g. http://Jenkins service, Jenkins, SVC, cluster local 8080. Can agent pods be reused? Yes, by setting idle minutes in pod template. To recap, always separate controller and agents into different namespaces. Use persistent volumes for state, implement preStop hooks for graceful shutdown, manage configuration as code, and monitor everything. Ready to go deeper? Up next, Jenkins Sonar Quebec Quality Gates, then Jenkins Credentials and Secrets Management, then Jenkins Security and RBAC. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.